Okay, if you're anything like me, bit of a sci-fi nerd, you've imagined that moment, right? When we get some kind of message,
Mm-hmm.
maybe in a bottle, from way out beyond our own solar system.
And it turns out we've actually received, well, 3 of them now, each one pretty surprising.
Yeah, the first was Oumuamua, that really weird, sleek space cigar thing that just zipped through. Very mysterious.
Right. Then came 2I Borisov, which felt a bit more familiar, kind of like a regular comet just visiting from interstellar space.
But this third one, 3I Atlas, this isn't just another visitor. It's like finding a 9.6 billion-year-old relic.
Mm-hmm.
If Oumuamua was maybe something out of Star Trek,
Uh-huh.
this thing is like an actual artifact from the galaxy's deep past, a genuine cosmic time capsule.
And that's what we're diving into today. We're looking at the observations, the sources, James Webb Space Telescope, Hubble, loads of ground-based telescopes too.
Yeah, the mission is to figure out, what is this thing actually made of? Where did 3I Atlas really come from?
Mm-hmm.
And why is its chemistry just so bizarre compared to everything else we've seen? So let's start at the beginning, the discovery itself.
Right. It was spotted July 1st, 2025. The NASA-funded ITAL system, that's the Asteroid Terrestrial Impact Last Alert System down in Chile, picked it up.
Just a tiny faint dot at first, magnitude 18, invisible to the naked eye, obviously.
But once astronomers pointed the big guns at it, well, the story got epic really fast.
And what immediately screamed Interstellar was just the pure physics of how it was moving.
Right.
It's completely unbound.
Unbound.
It's following this strongly hyperbolic trajectory. Think of it like its path is an open curve, not a closed loop like an orbit. It's just passing through.
Okay, so hyperbolic. How do we know for sure it isn't just like a really, really long period comet from way out in our own Oort cloud, maybe? That's down to a number called eccentricity. For 3ILS, it's measured at over 6. 6.1373 to be precise.
6. And anything over 1 means?
Anything over 1 means it's moving too fast for the sun's gravity to ever capture it into an orbit. It's got escape velocity and then some. Our sun just doesn't have the grip. It came in, swung by, and it's heading back out. Gone forever.
And the speed itself is just, wow, compared to the others.
Oh, absolutely. It's hyperbolic excess velocity, that's its speed way out in deep space relative to our sun, is a stunning 58 kilometers per second.
58. Okay, compared to Oumuamua was about 26 kilometers.
Yeah, 26. And Borisov was much slower, only about 3.7 kilometers. This thing is moving.
That kind of speed suggests, well, it must have been traveling for an incredibly long time, right?
Exactly. Billions of years drifting through interstellar space.
Now, whenever something fast and unknown shows up, I imagine the first question people ask is it going to hit us?
It's always the first question, and thankfully the answer is a clear no. We were never in any danger. Its closest pass to the sun, perihelion, that happened back on October 29th, 2025. It was about 1.35 AU out.
So between Earth and Mars orbits, roughly.
That's right, and its closest approach to Earth was even further out, about 1.8 AU, which is around 167 million kilometers. Happened in December 25. So plenty of space.
But here's something weird you mentioned. Its path. If it's just randomly zooming through the galaxy, why did it line up so closely with, like, the plane of our solar system?
That is fascinating, isn't it? Its trajectory is aligned within just 5 degrees of the ecliptic plane, that flat disk where all our planets orbit.
Okay, and the odds of that happening by chance are?
Very low. Less than 0.2% probability for a randomly ejected object from another star. Well, it's unusual. Makes you think, doesn't it?
It really does. Okay, so it's fast, it's on a weird path, but what about the object itself? Trying to figure out its size turned out to be really tricky, apparently.
Yeah, the main problem was this absolutely enormous cloud of gas and dust it was spewing out the coma. It completely shrouded the nucleus.
Right, so even Hubble, with its sharp vision, could only say the nucleus, the solid bit, was smaller than about 5.6 kilometers across. An upper limit.
And the consensus now is it's likely much smaller, probably less than a kilometer, maybe even just, 300, 400 meters across.
So tiny. But the light we were seeing wasn't really the rock itself. It was this huge cloud.
Yeah.
Huge is an understatement. Get this. Observations from the Grand Telescopio Canarias, that big 10.4-meter telescope, they measured the coma at roughly 26,000 by 24,000 kilometers.
Right.
Do you say kilometers? 26,000.
Mm-hmm.
That's LAS. That cloud around a potentially city-sized rock is about twice the diameter of the entire planet Earth.
Yep. Just an unbelievable amount of material being shed. It was an incredibly active comet.
And this activity started way out, didn't it? Not just when it got close to the sun.
That's another surprise. Looking back at older data, the TESS satellite actually caught it starting to outgas way out at 6.4 AU.
6 AU. That's past Jupiter's orbit. It was already active out in the cold.
Exactly. Venting volatiles when it was still very far from the sun's heat.
And the amount of stuff coming off, the dust production rate.
At perihelion, it peaked at around 405 kilograms per second, give or take 10 kilos.
To 100 kilos a second. Compared to Borisov?
Borisov was maybe 70 kilograms at a similar distance. So 3I8 Tels was either much bigger than we think or just way, way more active per square meter. Probably the latter.
And this activity explains how it got so bright, so fast.
It does. The brightening curve was incredibly steep. It didn't just get brighter proportionally as it got closer. It, accelerated dramatically, scaled as $7.05 near perihelion, which is really extreme.
More like some of our own really old active comets.
Yeah, more like the dynamically old, long-period comets from our own solar system, which is strange for an interstellar visitor. It suggests maybe the outer layers got stripped away, exposing super volatile stuff underneath.
Okay, this intense activity, this weird brightening, it all leads to the core mystery, right?
Yeah.
What is this thing actually made of? You said if most comets are snowballs.
Then 3ITLs is basically a cosmic dry ice bomb.
Huh. Okay, explain that. Where did we figure that out?
The killer data came from the James Webb Space Telescope using its near-infrared spectrograph back on August 6, 2025.
And Webb found.
It found the dominant volatile, the main icy stuff vaporizing wasn't water ice, HO. It was carbon dioxide, CO₂, dry ice.
Okay, co-Euro dominant. How dominant are we talking, compared to the water?
It's pretty stunning. The CO₂ mixing ratio was measured at 7.6 to 1 plus or minus 0.3.
7.6 times more kilos than water.
No.
That's huge, isn't it?
It's among the highest ratios ever seen in any comet, from our system or otherwise. It means it must have formed under really different conditions than our comets.
Like where?
Maybe really close to the CO snow line in its home planetary system where CO freezes but water might not as easily. Or maybe it got blasted with radiation that preferentially destroyed water ice, leaving the COs behind. We're still figuring that out.
But the CO₂ wasn't even the biggest chemical shocker, was it? There was metal.
Yeah, that's the part that really made astronomers sit up. Along with expected things like, hydrogen cyanide, HCN, and cyanide radicals, CN, they detected atomic nickel.
Nickel.
Yeah.
Just nickel atoms flying off a comet. That seems wrong. Like finding, iron filings in cotton candy.
It's definitely not what you expect. And it's not like solid chunks of nickel are just boiling off. The temperatures aren't nearly high enough for that.
So how do you get nickel vapor coming off a comet in the cold?
Well, the thinking involves some pretty exotic chemistry. The hypothesis is that the nickel isn't there as pure metal, but it's locked up inside complex organic molecules, things scientists are calling nickel-carbonyl-like complexes.
Nickel. Carbonyl. Okay, science jargon alert. Break that down. Okay, think of it like this. Imagine individual nickel atoms trapped inside really fragile cages made of carbon and oxygen atoms, maybe other organic bits too. These cages are very delicate.
Ah, okay. So when the comet gets even slightly warm or maybe hit by solar radiation, these organic cages just fall apart really easily. They have low activation energy, we say. And when they break, poof, the nickel atom is released as a gas.
Wow, okay, so fragile organic cages holding nickel. That's specific. And very unusual.
Extremely unusual. It points to a really unique formation environment. And combined with the CO₂ dominance, the spectral analysis suggests it formed in a low metallicity protoplanetary disk.
Low metallicity. We hear that term a lot. Remind us what that means for where this comet came from.
It means that the star system where it was born was chemically quite primitive, poor in elements heavier than hydrogen and helium, what astronomers call metals.
So not many heavy building blocks around.
Right, and typically low metallicity systems are very old. They formed early in the galaxy's history before generations of stars had fused heavier elements and spread them through space.
Okay, so low metallicity, rich in dry ice, carrying these weird nickel cages. This all points towards this thing being incredibly old, doesn't it?
And that's perhaps the most mind-blowing part. When researchers modeled its trajectory backwards through the galaxy, integrating its motion over cosmic time, the median age estimate came out at 9.6 billion years.
9.6 billion. Hang on. Our entire solar system, Earth, the sun, everything, that's only 4.6 billion years old.
Exactly. This object, this comet, might literally be twice as old as the Earth.
I can barely wrap my head around that. An actual physical object we can study that's almost 10 billion years old.
It's a direct sample from the early Milky Way, And its likely origin, given its age and chemistry, the evidence points towards the Milky Way's thick disk.
The thick disk.
Yeah, it's a component of our galaxy surrounding the main thin disk where we live. It's populated mostly by older, low metallicity stars. So finding an object from there gives us a pristine piece of what star systems were like way back then. It's an incredible time capsule.
Now, with anything this strange, especially after Oumuamua, there's bound to be some, well, speculation about what it really was, right?
Oh, inevitably, yeah. Avi Loeb, the Harvard astrophysicist who had unconventional ideas about Oumuamua,
Right.
he proposed an alternative hypothesis for 3I Atlas, too. He pointed to the combination of its size, its incredible speed, and that really weird low-probability trajectory near the ecliptic plane.
The 0.2% chance thing.
Yeah. And he argued basically that you couldn't completely rule out a technological origin based on those factors.
Did he give it one of his ratings? His Loeb scale?
He did, yeah. He assigned it a score of 4 out of 10, suggesting some possibility of artificiality.
Okay. But what's the mainstream scientific view?
The overwhelming consensus, and NASA explicitly stated this, is that 3I Atlas shows all the hallmarks of being a natural object, a comet, albeit a very, very strange and ancient one. The physics and chemistry, while unusual, are explainable through natural processes in an old, low-metallicity environment.
So regardless of speculation, the science focus is clear, and scientists are still watching it as it flies away. Are we still getting data?
We are, yeah. The observation campaign has been intense. JWST, Hubble, ground-based telescopes are still tracking it, and we're particularly looking forward to data from ESA's JUICE spacecraft.
Oh, the Jupiter Icy Moons Explorer. It's going to look at it.
It had observations planned for November 2025 as it heads out. We should get results from that, hopefully, by early 2026. It'll give us a look at how the comet's activity changes as it gets further from the sun again.
Okay, so let's wrap this up. If you remember just 3 things about this incredible object, 3I, what should they be?
The chemistry is just profoundly weird. It's a dry ice comet loaded with CO, not water, and it's got that strange atomic nickel, probably from fragile organic complexes. It screams formed somewhere very cold and chemically primitive.
Its age is just staggering, estimated at 9.6 billion years old, maybe twice the age of Earth. It's a physical piece of the ancient Milky Way, likely from the thick disk, a true time capsule.
Finding a third interstellar object in just a few years tells us that planetary systems throwing rocks and ice out into the galaxy is actually a pretty common and efficient process. The galaxy is full of this traveling material.
It really makes you think, doesn't it? These cosmic delivery trucks.
Yeah.
If 3I could travel for billions of years, carrying complex organics and weird metals from an ancient star system, well, it kind of boosts the whole idea of panspermia, you know?
The idea that life's ingredients, or maybe even simple life itself, could get seeded across the galaxy. Yeah, these objects show that the transport mechanism is definitely there. So here's the final thought to leave you with. If this nearly 10 billion-year-old piece of dry ice brought us nickel trapped in complex organic cages, what other kinds of hidden, ancient cargo might the next interstellar visitor be carrying across the void? The universe is definitely sending us messages. We just have to keep our telescopes pointed up and keep listening.